Hello everybody, thank you for clicking on this video, thank you for checking it out. And yes, today is day 17, or actually it is day 18. I completely messed up the title. It doesn't matter. Day 18 is today, and we are learning as we're going in the course DoubleJump Academy's workshop, Houdini for games. And we're learning some couple of things. We first started with a bridge. We made a procedural bridge and it broke and it looked amazing. We learned tons of things, how to make an HDA and how to put that HDA in Unreal and how it breaks and etc. and all types of cool things. And then we are now learning in week 3 about destructions, how to import destruction in Unreal and make it work. So yeah, stick around and we will keep going from day 17. We started yesterday with the destruction stuff. Things didn't work, but basically I got a feedback from our mentor, Grayson, and he told us that, yeah, we should just check the project file that they provided, which is something I haven't thought about, honestly. As easy as it sounds, but I haven't thought about it. But they have provided us with a file, and here it is with a DGA procedural thing that they are working with, and we just should check the structure and the namings and everything else, and we will do that. We'll go one by one, try to compare it to our procedural work so far, see where we have made maybe some mistakes, maybe the structure was not correct. So yeah, it's very heavy on that. Maybe the Vex code we wrote yesterday was not correctly written, so we will just check all of those things today. If you like to stick around, we will basically stream for 6 hours, let's say, today. Maximum, let's say. And let's hope that we get some nice content for you all to, I don't know, check out and learn from or communicate with me about or whatever. Build a community. Let's keep going. And yes, so we will pause the recording now. I'll be right back with you. All right, everybody. So we have found a solution. We have followed and compared the actual project that was provided to us by DoubleJump Academy. Thank you for providing those files. And basically, we followed through the steps, and I copied the attributes and what I found, and also copied the structure of this thing. So first of all, we realized that the Unreal material was before the exploded view. And that is what I've done here. So those are some of the fixes that we've done. So I realized that they had their exploded view after the Unreal material. So that, I think, had solved some type of problem. And also what I noticed in their main file is if you go backwards, you have an auto UV for the actual cube before everything else. And we have made this whole split thing, and we did like a spaghetti of different nodes, and we didn't have to do that. So basically basically we needed that here. So what I did is I made into I went one back in the hierarchy, added the auto UV as you can see here, and then what I did, one last thing I've done is inside of the Houdini to Unreal logic, inside of here, I have actually copied the attribute triangle with all the code. This is where they wanted us to copy from in the course, but I didn't check it. I didn't get it. But basically, when I first started with this, it was like, whoa, what the hell is that? It's so many things at once. And then I was like, what is this thing called in the video? And they named it initialize Unreal Physics, but I couldn't find it. So I went on, does Houdini have Control F? And I went into Control F and I looked for it, initialize, right? Initialize Unreal Physics, and it goes like right there. It snaps into it. If I choose another thing, it snaps into it as well. And so what I did is just I went here, went into our Unreal attribute, copied that one, and went in here and I pasted it. And yeah, this is how we have that now. If that had caused any issues in the past, maybe now it doesn't anymore because we have the proper code, we have everything properly. Good. So I might have misspelled a letter or two in there, so maybe that is why things are not working. And I can't wait to show you the result in Unreal. I have tested it, and also what I noticed is when I re-imported that HDA, it kept all the problems with it. I have no idea what that happened though. So what I've done is I deleted all the HDA that I have in the scene, and I have made I basically re-imported the HDA, I rebuilt everything in it, and now we have a cool. Whoa, dude, what's happening here? Escape. Why is all the... All right, now it's working again. Okay, and now we will hit on play and check what is happening. It goes down. Boom, here you go. We're having some type of explosion. Good. And now we'll hit it with a cube. Torture it. Boom. Break. Ah! Okay, so here you go. We have it. Cool, isn't it? Cool. Let's keep learning, and we will see how things will go from here. It's pretty cool how those things work. I will make a little Instagram story just to tease people to join. All right, that's it for now. Let's stop the animation, and we'll be right back with you. Enable the recording, and we will say, all right, so we have selection mode in Unreal, we have landscape mode in Unreal, foliage mode in Unreal, mesh paint in Unreal, modeling in Unreal, fracture in Unreal. Fracture, that's the word we're looking for. Fracture. And fracture it is. Good. Let's check what this thing does. And according to Grayson, that's where the magic happens. So we'll see what that means. What does the magic happens mean in that fracture mode? Okay, so we will probably have to select our Houdini HDA right there. Click on it. Wait a second. All right, and here we are. And now we'll be able to, in this outliner here, I suppose, if you have explode amount, that should mean it should explode. Let's try it. Does it work? Are you here? All levels. Let me try to think. Do we have to go here? Oh, we have to go into the child of the Houdini file. Oh, and it breaks. That's amazing. Okay, we'll be right back with the... We're back at it, everybody. Oh, you're drawing and Procreate. Cool, Tova. I'm very happy for you. I'm very happy that actually drawing helps you out and makes you feel better about yourself. That's pretty cool. All right, so yeah, we have explode amount, and it goes like this, but we can still see the cube inside. I don't want to see that. So let's go cube. Cube. Bye-bye, cube. All right. What are you drawing, if I may ask? Enjoy breaking things in your day. I will. Literally breaking things. Yeah, all right. I see you around. Don't worry. So let's see Houdini. All right. This thing is exploding, and it has explode amounts. Good. It goes from 0 to 1, and I like how this thing goes. I bet we can animate that, so later on. 2. No, it doesn't go to 2. All right. So fracture level 0 is nothing. Fracture level 1 is... Oh. Okay. Interesting. The moment I basically made the scatter amount way higher in the HDA, it basically broke. Which is interesting. And what does the level 2 mean? Level 2? Okay. What we see in the level 1, though, that some parts are still clustered together and they're still hooked to each other. Okay, I wonder what happens if we have a bit more... how to say, like a little bit more scatter here. Let's just put the exposure amount here. Like you see, this is amazing. It's so cool that it does that automatically. That's awesome. Okay, so what we will do is try our best now to go through the... Let me check. We will get the scatter amount a bit higher. That's for sure what we will do. So yeah, let's do that. Let's go into our scatter amount and go up to 800, and this will cook everything again. So I'll pause the recording. Finally, I'll be able to record again. So after a lot of problem solving, around 2 hours of problem solving right now, we have created a whole new Unreal project. We have created we have renamed our Houdini HDA to the same name from before. I think the naming here was wrong. It had played with something else, and I renamed it here as well. So this was not the same name before. It had an HDA in it, .HDA in it, and I think it was messing things up. I was not sure, but I was like, let's just be clear. Let's make everything again from scratch, and we have done that now. And so I created a whole new Unreal project, and I imported it just clean, start a new session, and everything is clean. So this is the result so far. If I start the simulation, it breaks apart. We have our concrete material from the inside. Things are looking good, and now it's not creating any extra children. As you can see here, every time it was baking, it was creating a new child. Hey Hershey, nice to have you on Instagram. We will basically hit it now with different particles. Here we go. We're just gonna hit it with different boxes, and it's gonna break apart. And now it has 1,000 scatter amount, and we're just gonna destroy it like that. keep going. Here we go. It is working properly. It's not exciting yet, of course. It's nothing exciting. Material is disappearing for some reason after some points. But yeah, it is what it is. I think we need to change the outer material too in order for it not to disappear. But for now, fine enough. We're gonna stop the simulation, and now we will go again into our fracture points that we were creating or covering before. So if you go into the mode here in Unreal and you go to fracture mode, and then it fractures, it crashes again. That sucks. And I have no idea why it's breaking. If you're watching this on YouTube and you know why it's breaking, do let me know. Okay, so as for now, I have to click on the child here to make this visible, right? So right there. And so if I go inside of so if I select here, I could select the actual the clusters themselves, and we could see inside of their attribute here, that is how it's communicating between the CG name and the cluster itself. And this is how we were able to group things differently before yesterday when we were on the stream. And this is how it's grouping them. If I may show you it inside of the Houdini file, it looks something like this. Okay, so we have our pack that had packed our GC name, and I'll show you what that means in a second. So if I go all the way up and I expand this a bit here, and so if I go inside of here in the UV random, now wait a second, which one do we need? Explode view? Nah, in the Unreal Logic here, and I go inside of our attribute wrangle. If I go and I check our attributes, we see an attribute called name. The attribute name in the cluster, after the cluster had been contaminated with different data because it was creating its cluster values right on top of it. And it looks like this in the spreadsheet. We have our name, and it had named some of the geometry into cluster and then again into pieces, which is the original name. And so what we've done here with the copy is that we copied that on the side. And I'm reviewing that again and again and again because I barely understand it. Okay, and then at the end we packed only the GC name, so we still have chance for fracture. And this way we have grouped all the fractures into one node called name, GC name, that we copied from the name before it got contaminated with the cluster. And here we see that happening right here. If I choose level fracture 2, this will change again. And the ability of doing that is happening because thanks to the grouping, the smart grouping that we created. All right, so far so good. We understand that, and we see those clusters are allowing us to group things inside of them. So they're taking our fractures and they're grouping them right there into a cluster value. Okay, so if I go back to level 1, we have the clusters just like normal, but we're able to have level 2 as well because of the grouping that we made. And I think we've added some of that in the code, if I'm not mistaken. Let me just check it. And furthermore, in understanding how the system works, we will promote a couple of parameters inside of Houdini. So let's open the menu here. And let's go a step back into the object, and we'll go to week 3 geometry right there. Just gonna load, it's fine. And now inside of our HDA, we'll right click and add type parameters, and we should be able now to promote a couple of parameters. Let's see which parameters we will promote, and there will be the parameters of the cluster itself. Just gonna put it a bit to the left so y'all could see it better. The cluster itself, and the cluster here will be let me check. We will promote a couple of things. I remember by just memory we could drag and drop things. So well, first we need a folder. Let's apply a folder. Can I just click Control New? All right, no. All right, So we will get a folder in here. We'll call that folder cluster controls. The cluster controls, we would like to add the size, and we would like to add the detach ratio right there. Put them in the file, and instead of having only size, we'll add cluster size, and this should be the name of that. And same here, detach ratio will still be the same. So we'll apply those changes and accept them. Right click on our HDA and save the node type, and then we'll go right into Unreal again. Right click, and hopefully it won't break. Rebuild all instances. We will wait for it to rebake and recook everything. Cooking was done, no crashing. Good. That means we are on the right track here so far. What we will do now is go into a property slowly, and instead of level 2, we will have a level 1. I will show you now what that did now so far. If I go to the Houdini attribute, to the HDA, we should be able to have cluster size. So our folder basically, and we should lock those things. And if I have chose, for example, a value of 2 here, it should give a bigger cluster amount. So the size, the cluster size should have now more stuff clustering with each other and hooking up with each other better. It will cook probably. If we crash, we crash. We'll go back into the child, and here we see more of things got clustering together because of the cluster size. That is what we've done with our parameters, and we could add one more thing with our detach. Well, we just have to go to the Houdini HDA first, and we'll add some detach ratio of, I don't know, let's go something high, 0.8. We'll let it cook. We'll let it basically calculate some of things, and we'll be right back with you. Good, nothing crashed again. That's amazing. We have more detach ratio. We have more things detached from each other. And for now, we don't want that type of effect. So we need the opposite of that effect just to see if things are working properly. So instead of detaching them from each other, we want to keep them together. So 0.05. We're just going to keep the clusters together, and we'll let that cook and bake just to understand what that parameter does. Okay, we'll be right back with y'all. Good. So as we can see here, this is how it would look like now if we have increased our detach value. And one more thing I want to test with y'all is the scale. So if this was on 2, now we have a lot of clusters, correct? So if I put it on 0.5 or 0.2, everything broke. Just all the stream broke, all the recording system broke, and we're figuring it out as we go. I think my GPU was overloaded, but now it's TMI. Anyway, let's dive into where we left off, and I'll continue with the course and let you guys know what happens next. Basically going to put some elements together here because otherwise it's too crowdy. So let's do that. Let's just put things together, and this menu as well together here. I mean, that's fine for now. Let's keep it here. All right, so let's make this a bit bigger here as well. Why not? All right, so in the details panel and in the outliner, if I go to our HDA, which is right there, and I click on the details on the child of it, and then I drop into the menu down here, and I go into the what is it called? It's called mass. So reset collection, this one right there. If I click on it, it should pop a new menu up. If I click here, maybe on this, yes, here we are. It's a new menu, and it gives us this those stuff we had. For example, we have enabled the mass here, and we can give it a value. And so this value now, the higher we get it, I think the more mass the thing will get. So we can add that up to a 5,000 just to see what it does. And we can save it and then close it and then play this as a simulation. Might need to bake it again, might not. Ooh, so the bigger the mass, the bigger the explosion. Okay. That's kind of cool though. I like that one. Let's try something lower than that then. Double click on the thing. You'll go back into that menu, back again. Let's give it a value of 100. Let's see how thick this will make it now. So save, and let's see if it will break. All right, play that, and let's see what happens. All right, it's quite bouncy. That means it is very light. I think if we... Whoa, breaking, break. Wait. Play that again. All right, that's good so far. What happens if I move one of those parts and I kick it with it? Yeah, it's definitely hard to break, but it's very, very light. That means the mass has something to do with... that's lovely. It has something... Oh, whoa. So yeah, it definitely has something to do with weight. And of course, the more weight, the more damage it will take from the fall. So, whoa, that's kind of really neat right there. All right, so we will stop it and try different type of methods to make it break. Let's see if we could change more things from the code that we wrote. So we have a mass, we changed that. Now it's quite light, right? We could change the type of collision inside of the collision shape. So let me just write collision. Cool. All right, and then I go here. Remember when we were changing those things and we chose by numbers 2, 3, 4, 5, and now I will try to choose the convex and see if that works. Save, close, and hopefully it doesn't break anything. All right, good. So it's still going. Let's see, let's hit it with some cubes. Boom. All right, it is breaking apart. That's quite cool. I wonder what that collision meant now, what that type of collision meant now, the convex one. And I wish there was an explanation for it. So if anyone in the chat knows what it does, guys, let me know. All right, so for now, I think I would like this to stay on the ground, kinda, and would like to give it a mass. So let's give it a huge mass, like a 5,000, and check how that changes things. So, max size, blah, mass, let's give that a 5,000 again, and save it. It should break apart completely. At least that's what happened last time, but I think that happened because it was so big. And it was so far away. So the mass was incredible. So I think now pushing it will be hard, but it will break like that. Here you go. That's so hilarious. It's cool though. I think we can as well like change the cluster amount and the scale and the detachability of that as well. But I think it's affecting the mass is affecting a lot of it, honestly. All right, but that's really cool so far. I love how the thing can't go through it. It can only go on the top of it. All right, but that's awesome though. Like so far so good. We will continue and play with other things. And yeah, all right. It's a good stream finally. Finally we had fixed things. And let's, I'll be right back. So we'll go through this. We will basically add the following. The simulation is off, that's good. We will make parts of that cube not break at all. And we'll see how that's done. Okay, so let's go through it. Where's our Houdini? Is that our Houdini file? No, that's our Houdini file. All right, great. Okay, so first of all, we will add 2 inputs for our HDA here. So we did that before. So type properties like here. Put this thing in the middle. And then go to the basics. And in the maximum inputs, just pull this to 2 right there. Okay, so y'all see this. Maximum inputs. 2. Okay, now parameters, and in the parameters we do nothing. In the nodes we do nothing. In the input we do something. Now we didn't save that to minimum input 2. Let's see, let's apply that, and then in the input, okay, so that is not working. Let's go to maximum inputs, not minimum input. Minimum input would not help anyway. So apply that, then go to input right there. So we have input label number 1, and that label should be called fraction shape. That is our current box where it is right now. And the second one will be called fraction region. So that is the region that is allowed to be fractured. Okay, I have to charge my keyboard. So I'll hook it up to the cable right there. Hope y'all are feeling good. All right, so the thing is hooked up now. Okay, so we apply that fraction shape and fraction region. Okay, so apply. And that will be applied now. Good. And then accept it. And what we'll do now, just for testing, we'll add a sphere, for example, or any type of shape. So I will add a cylinder, maybe. Cylinder, just to see how would that look like. Let's look at it. And let's give it, let's put it, so inner radius, let's see. Yeah, let's make it a funny shape. Why not? Because we can. Less geometry, not too much geometry, and the height we could manipulate as well. How is that in reference to the box? So if we make the box a template, it's way too big. So we'll make its scale into 4. No, not 1. Sorry, those are the slides. Okay, so slides 5, fine for me. And let's see if we, yeah, we can definitely take this down. Here as well. Okay, and let's take its height, put it down a little bit. That's funny shape right there. Okay, I'm not sure if it would be a good idea, honestly. Okay, so let's not go that route. Let's try a sphere. Let's try a sphere, and let's see how the sphere will look like. Okay, how's the sphere in reference to the box? If I put this into template mode, cool. I like this effect. Might we? Yeah, we might just go with it. All right, so then inside the input 2 is now our fracture region. So what we'll do is make this whole thing bigger. Okay, so let's go now one by one. All right, so this one, the number 1, is our input number 1. No, wait, this is not the actual. This is the actual HDA. We are inside something else. Okay, so 1 and 2 right there. All right, press Shift S to have a better connection to those things. All right, and now what we will do is finally add a switch if, and that is a new node, a switch if, and we'll see what it does in a second. First of all, the one thing we need to change here is our test input. Test input says for test below based on geometry, use the geometry from this input that shows it input always cook. So we either go with the first input or with the second input or with a spare input. We can go with a second input, I think, for this one. Let's check it out. Let's put this one here and this one here. Of course, now we won't see anything, but right now we're seeing the second input, which is the sphere, because we chose the second input. If we choose the first input, we will go with the first input. I think it is not changing. Number of tests, clear, test type expression, attribute presence, element count, attribute value, or input wired. I think that is the one we need. So let me check let me just read through our test type. What type of tests to perform? Expression, I think, is code. Attribute presence, I'm not sure. Element count, I think, is the count of the element. Is that the points count? I'm not sure either. Attribute value, I think, is something we could basically write here. And input wired is the one we need here. As for this, we'll keep it on the first input. And I'll try to understand a little bit about the switch if, and we'll be right back with you. Working, everyone. All right, so we change it to second input. And now we are going to hook this up in the fracture region here, the fracture Voronoi fracture, and inside of the ISO offset right there. Okay, so if I take the ISO offset now and I look at it, it's taking the sphere. And basically, we don't need that type of behavior. I'm not sure, though. Wait, let's see the end result. It's taking the sphere as a shape here. Yeah, what are you doing? Let's see. All conditions true. We can also change that type of behavior. Okay, let's check which behavior we took here, just to pay attention a bit more. Okay. I think I get it. So, since we have a couple of things now to do. All right, give me a second. So we need the sphere to be a bit bigger than the rest of the thing. So uniform scale, go a bit bigger than the actual cube right there. And this should already give us that effect, that desired effect we wanted, I think. Volume, no. All right, let's go with the Venoroid. Okay, also nothing. What I was wishing for is like some type of boolean that keeps the box out. So let's try different things. All conditions are true. Any condition true? Nah. All right. All conditions false. Yeah, but any condition false. All right. We're not getting anything from this. We'll go back. No worries. I think basically the sphere was too optimistic to make this work. That could be due to the type of data the sphere has. It could be because the sphere here is a polygon mesh, while the box is also a polygon mesh. I have no idea why this is not working. Okay, so we'll add another box here. We'll check it out. So boxy, here we go. Let's make that box a bit smaller in size in one of the axes. Yeah, smaller. All right, that's that way it won't go with us, so let's go with this one. All right, smaller now. Okay, and let's see if that would work with our, come on now, 0.8, fine by me. Let's not do it with the middle click. Fine, good. Now we can see that it is actually working. It is taking the fraction. All right, so it doesn't really have any difference. Or does it? Wait, let's go all the way to the Vernoid. But that is exactly not what we want though. Wait. I'm doing it all wrong here. All right, so wait, let's take that, put it in the one. Okay, and now after the switch if, hey, Miss Dolphy, how's it going? After that, we will check the scatter. And yeah, kinda. All right, so but we still need to hook this up to know the difference between those two wires. And then once it goes in here, we should have the difference, right? Scatter is not, but the scatter is only happening inside of this volume. So far we know. Look, this is what's happening. All right, so give me a break. What we'll do is go into transform here. And oh no. All right, so we're going to transform, tab transform, here we go. And we will basically put that thing inside of here. All right, and now basically we could play with the scale a little more. So if I put 0.5, it will take it into half, and look at that. It's making those areas stick together more and these areas not stick together. All right, so if I template this view, we can see where this effect is actually taking place and which is inside of that. So let's review a little bit. Let's do a bit of a revision of what is happening here. So if I go a little bit back, and we have basically so far added an input, and this input went into our HDA. So far so good. And once we have added that, we basically have added a transform if. The transform if is doing the test on the second input, not on the first input. So it's taking the input from the second input here, this one, and it's doing use second input if all conditions are true. That means if only use the second input if they intersect with each other. I suppose that's the case. And then we basically add the test type, and we called it input wired. We still don't know what that means completely, but we could have like made it into an attribute value and have it only work with an attribute value. And we have the ISO offset afterwards, just like the normal setup we had before. And then, but most importantly, we hooked the square inside here and also continued hooking it up into the hierarchy. So what I will try to do now is I put a sphere again. So let's do that, and I'll make that sphere a bit bigger until it goes out of the actual geometry. So let's keep the box here as a template and just review. Okay, so now if I go inside, we see that that sphere is only acting. Wait, didn't work yet. Hi Vista, how's it going? How's it going, Miss Dolphin? How's it going, Vista? How's it going, people on YouTube? Thanks for joining. Okay, so let's see. We have a sphere here, and we will hook that sphere inside the second input, and now we will see different things happening, as you can see here with the transform value and everything else. we have rigid clusters here that are not as noisy or don't have as much scatter as the rest of the region. So if I go with a scatter with something crazy here, like for example 1,000, we'll see that 1,000 happening in that region and not much of it happening in the other region. So if I go up to our object to week 3, and then I will go to our HTA right there and basically do here the scatter amount, keep it up to 1,000 just to see how would that affect our scatter, and it should scatter inside the sphere only, and here we see that it is only doing it inside the sphere. All right, so far so good. We have completed that process so far. All right, so what I'll do is I'll pause together. People, let's go in here and check it out. Okay, so we have a sphere, a transform, a switch, an ISO offset. All right, everything is fine. Now what we could do in between those two steps is basically let's add a pack. So when we add a pack, we're packing all those information together that we decide to pack. So if I put name attribute here and I keep the name in here and I hook that inside of here and I check its points, it's saying 800 points. Well, let me check. Yeah, because we have it on 1,000 scatter amount. Let's keep it on a 200 scatter amount. Now check the details. It says 188. That is great. That is less than 200. That means only the middle part will will split. Let me read the comments. We'll be right back. I remember now what we were doing. The name thing is packing right now the name attribute from the piece. All right. So if I go into, all right, here we go. So we have an attribute called name right there, and it has all the different pieces. Keep in mind, this has not been yet hooked to any cluster. So this is only the number of the pieces under the attribute name. And so when we packed it, we have packed 188 pieces. Okay, now why did we do this? Why did we do the whole thing? All right, so here's what we're gonna do. We are going to group things, and we're gonna smart group them. And what does that mean? We will use bounds. Okay, so what are bounds? Bounds are like masks in Photoshop, if you're familiar with that. If you're not, I'm gonna show it to you right now. So use the pack, put it here, and then take the bound and take the null from that one, from the second one, which is the sphere. So let's add the null right after the transform, so we are on the same page. So null there. Here we go. That is out sphere out clean. Sphere out. Let's just say sphere out. Here we are. I know y'all can't read this, but I did it very far away. I didn't even read it as well. I wrote sphere out. Okay, not that it matters. Doesn't really matter. Okay, so check this out now. If I put that in the bounding object, and you might not be able to see it, but here it is, bounding object. This should group now. Whatever we tell it to group, right? We'll give this group name, and we'll call it active. All right, so active selection. All right, so it's just called active. And if I go now and I check the keep in bounding region and I enable that, I should be able, once I take that, whatever is coming out of this group right now, and I put a null on it, we should only be seeing the inner values. Let me check. I might have missed something, not the bounding region, but what is it called? Include by edges, keep by random. Let me check. Keep in bounding region, bounding brush, bounding sphere, and bounding object point vertices only, bounding volume, bounding convex hull. But there was an option where you could choose the actual bounding and where it comes from. Well, wait. Bounding volume. It should take it from the input. Bounding object, I think. Didn't work. Okay, give me a second. We'll be right back with you. All right, so it is the bounding object. So we'll go and bounding object. So it says points or vertices only. So we might need to change this to points. Here we go. and it is actually grouping our bounding objects. So we have the pieces, the actual pieces, which now ends up to be in the null here. They're still 188. I wonder. I think we need to split that in order to be able to view it. So let's split that. Let's split our active and check what happens. Yo, split us active. Here we are. And that is where the sphere lives, so to speak, inside of that scatter. And if I take the scatter up to 1,000, it will get better shape into the sphere itself. And if I template the sphere inside of here, you will see that it is definitely right inside of it. And if I change the size of that sphere, so if I go into the transform and I play with that input right there, we will change the bounding box and the grouping of that certain thing. All right, good. Now we have it like kind of inside, kind of outside. I kind of like it. Let's go with a 85 right there. Maybe 83 right there. Yeah, something like that. That might help us. Oh my god, my back hurts as hell. Good. Now let's check our null. All right, so that is right after the split. So this is active split. And what we'll do is, I love the split logo here. It looks like a banana split. Anyway, let's keep going. Let's pause for this. Let's learn how to do this. So we have definitely packed things, and that could be for the good or for the worse. For now, it is for the worse. Okay, so what do we do? What do we do? How do we deal with something that we have packed? We need, before we continue into the app operation, if we wish to, we need to unpack it again. So right here, right after the split, we will add an unpack because that data is, it's not workable. You can't work with it. So we'll just hook it to the unpack again, but at least we have the actual geometry that will break, right? So let's hook it up with the rest of the operation. And if we hook it up right there, for example, this should give us the ability. And if I check the explode here, we should merge. I think we should merge a couple of things. All right, give me a second. I will be right. So let's get this thing started, everybody. All right, so we have split something here. We have definitely split whatever is inside of here from whatever that was outside of it. So if I take a null here, right, and I put the thing in it, boom, and we see the rest of the cube, right? Now we can either decide now to make everything else but fracture, or everything, or the other way around. When can I see your stream? Do you have a YouTube or Twitch? Of course I do. Check. Of course I do. And please check the links in the bio. Please check the links in the bio, my friend. All right, so I wrote that to Ahmed Al-Badri, who is a veteran into where I started, which is manga coloring, as the name DOV. And Ahmed Al-Badri is my friend from there, so a huge respect to Ahmed Al-Badri. All right, so let's keep it going, everybody. So now we know the split had split either the inside or the outside, and now we can do different things with each one of them. Now, before I continue, I would love it if I create a group, and instead of the group being here active, I would like that part to actually be the inactive one. So I will flip the whole thing inactive, and I will make that group the active one, because I would like the active part to be the one that actually wait, first let me update the group name here. Never forget that if you update the name, you have to update it everywhere. We have more questions. Let me just pause to call that part the active part, correct? So let's call it that right now in the group right here, and we'll call it active. You are our active group, because we want that group to be the active one. Actually not. We wanted the other way around. Actually, so it was correct before. So it is what it is. Let's do it. Let's call the active one the active one, and the inactive one the inactive one. So let's just keep it like that. Let's keep it organized as such. Give it a second. So people, we have created some stuff. We will create a subnetwork. So subnetwork inside of here. Boom, bam, done. And now we will take the inputs here and put this group into one of the inputs. And if I go inside of here, then basically we need to give it a name at least. So the name they gave it here is called initialize static collection, I think. All right, so what we will call it, initialize, or wait, what is the other alternative of it was? One with the Unreal, this one Houdini to Unreal Logic. Let's make this one pink. Why not? Pink is amazing. Okay, so we'll put that thing right there, and we'll put also this one pink, and this one is Houdini to Unreal Logic. This will be collision. Houdini, actually it's a different type of thing, so let's give it a blue for collision. We'll call it collision initialize or create collision for inactive. All right, amazing, we have it. Create collision for inactive, and this should now give us the ability to create, we should create that subnetwork basically and start working on it. Hey Jack, now we basically will start creating our collision inside of here so that Unreal can say, yo, that's a collision, and we'll generate it procedurally. That's actually quite cool. That's really cool. So let's do that. I'm very excited for that. So there's something called VDB. VDB from polygons, right there, people. All right, it's just gotta go a little bit backwards in the video. So it is true, it's VDB from polygons. We will hook our main mesh into that thing and view it. You can see that this is like a resolution thing. It's like a remesh thing. So I'll put that a little bit down here. We're creating like an eye. It looks like an eye socket. So, but it is actually not an eye socket. So in the voxel size right there, the lower the number, the more resolution you're putting, right? So if I put 1, it will just turn into this pixelated, weird looking thingy here. And we don't want that. So let's go with a 0.008. And this should give us a really nice resolution into like what is our mesh, right? A representation of our mesh. And if we convert that, and I will show you what that means right in a second. If we convert it, all right, so first let's take the word convert and add VDB. All right, so VDB or convert VDB, and if we put it in the first input right there, it should have converted it for us. We have a lot of comments. I'll read them in a second. I'll be right there with you guys. It should have given us the ability to see the borders of the collision, but I think it's unfortunate because, no, wait a second, I think we need to change that to polygons. Here we go. And if I view that, we have 151,000 points. That's actually not so bad. At least that's what they tell us in the course. We will learn how to basically work with this in a bit. I'll be right back. Oh, let's keep it going. We need a convex decomposition. I have a lot of comments, so we'll check them out in a second. So right after that step, we will use something called a convex decomposition. And decomposition here should basically give us the result of that convert. Let's check it out. Okay, so that is, as I thought, something that wouldn't make sense in the case of our, unfortunately. It just won't make sense for what we're doing here. Maybe if I change it to VDB, it would change something. I think it's not reading it anymore. I think polygons is changing it into this. Polygon soap. Ooh, that is actually not so bad. All right, so, but it's way too dense. I mean, is there a way I can divide that and make it into something that is workable? That is one way, I guess. But the convert thing should anyway make it less dense, right? But it's not doing anything because it is actually working with, what is it working with? Convex hull segmented geometry. Would this make any sense? It's only working with a polygon. Is there a way I can convert to polygon? Convert. All right, let's convert it. And all type to polygon. All right, sounds good. But whenever we're converting it, it is not working. Okay. I wish I knew what to do here, but I don't have that much experience. Well, I can always ask later. So what I will do is make a screenshot out of this. And we gotta solve this hopefully later. So let's do that. I'm just gonna screenshot that. And here we go. And we'll save it. I think someone in the Discord server even had the same problem, but I'm not sure. So I'll just save it in the downloads for later to share. Okay, good. Saved. Nice stuff. Good stuff. Good. Then we have VDB from Polygon. Okay, so what we will do is change the type of stuff we were doing and change it to the same way they have made it in the course. So the box. Yo, box, what's up? All right, so I want you to take me here and go in the 1.8 instead of 0.8, and I want you to go in the translation center right here. It's too big. All right, so here, right there. Okay, I wanted to have this value right there. Okay, so far so good. And then we will hook it up inside of here. Then we'll go to transformation inside of it and bypass that. We don't need it. Okay, so now we have two parts. One is active, which is let me check. All right, so active part is after the split right there. Okay, so this is the active part. So this is the thing that will split many times if we shoot on it like a wall, right? And the other part will stay as is. Okay, so now we will need to create collision for this. So let's do that. Collision, here we go. And right after the convert VDB, we should have, this is a polygon sub, we'll turn it back to polygons, and we should have this now. All right, so we're having the same results like in the course. We will save that and learn some more. We'll be right back with you. What I've learned is that we could take that number to a lower number, so 0.8, and it will become more accurate. But it takes time until it reacts with us. So let's do it a bit lower again and pray it won't crash. So let's see if it's gonna crash. All right, so let's go with 0.1, 0.4 maybe. That's not changing anything. 0.1, is that changing anything? It's loading. That's happening. Let's give it some time. Here we go. We are getting some results. No worries, Robin, you got it. I am using educational version, the education edition. It's one above the apprentice. It costs around $75, but you just have to basically confirm for them that you're studying in either a school, university, or or you're like part of an online school such as DoubleJump Academy, because they're partnered with Side Effects. So yeah, check that out. Yeah, definitely get that in check. They actually have a very good course right now. I'm gonna post that a bit. Actually, let's put it in a video, it doesn't matter. They have a very good course about back engineering or reverse engineering effects from movies, and I really think that's quite attractive, and I would really love to start that as well, even though I have no interest in VFX but in movies. But it's quite interesting, the concept of how you can reverse engineer something, because it's just attractive. It's exactly who I am. You can't put me in a box. I can do everything. That's what I want to be, right? So I don't know, I think that's quite cool to be able to reverse engineer things on your own. Like, that skill set on its own sounds very attractive to me, and I would really love to know how that's done. Anyway, that's just from me to you as like what is exciting about the courses they're offering. Otherwise, there's those free tutorials and free workshops they're offering, man. These free things are amazing. All right, we have someone joined on Instagram. Gooprees7, nice to have you here, my friend. Okay, so let's both. So now we learned that if we change that number, we get better results. If I put this into 0, 7, we should get a bit more details. I hope it won't crash. I hope it won't crash. All right, look at that. Look at that. Yeah, it's broken a little bit, but it's anyway, it should just reflect a collision. Let me pause a thing with our object from before. So our sphere, let's hook that up inside and not bypass our transform. So keep the transform. And now let's check if that will actually change our convex, what's it called? Convex decomposition. Let's see if that will, with the 0.1 now, if that would change anything. We will keep looking at it. All right, so here you go. That is much better, honestly. That's good. That's pretty good, guys. All right, so let's keep that. Maybe we add a bit more details. Just maybe a 6.5. This might crash Houdini right now. It will take some time. It will compile. Let's let it compile. Please compile. Please compile. No stress. Just make it work for me, please. All right, here we have it. That is our collision. It's a lot of details for a collision, but it's not that bad. Am I right? I mean, do we really need collision to be that detailed? I don't think so. But yeah, let's see. I think that is a bit too much, too detailed. Let's go with 7.5. Let's let it bake. Let him cook, man. Let him cook. All right, people, go into side effects. Side effects /also.com. docs/Unreal 16.5 collisions, and now if you go here you will be able to read about collisions from Houdini engine to Unreal. We will read through this on the stream and I will leave it out from the recording because it might be quite lengthy. There are 3 types of collisions. We have complex collision, convex collision, and simple collisions, and we'll read through that. So far we have learned that colliders are created by assigning your geometry to groups, so all of them will be part of group. The naming convention of those group matter, and the name of group will decide which type of colliders it will create. So we have to add in our naming group which type of the colliders, either convex or complex or simple. All right, so let's keep going. That the complex is more expensive. Complex collisions are more expensive than convex collisions due to some reasons, which I don't yet understand. But I might actually put the whole thing in ChatGPT and tell it to explain it to me like I'm 5. But we'll do that a bit later. And so far that the physical simulation would not be possible in both those types of colliders, the complex one and the convex one, as only raycasting collisions are supporting that type. We also had learned so far that collision geo will make your collision invisible, as in the middle of picture, and render collision geo, if you put that in the naming convention, it will make it renderable, like we see here, I suppose. Okay, good stuff. Let's keep going. Actually, it is actually described here. So from left to right, no group, no collider, nothing. Collision geo, invisible collider. It has the invisible collider right there, which has collision geo in the name, and then rendered collision geo has visible collider, which we see right here. So if it is called collision geo, it has no collider and no visible collider, sorry. And if it says rendered collision geo, which is in the name, explainable right there. So we have learned a little bit of stuff. We will check the rest of it now. All right, so we learned some new stuff. Simplified collision geometry are important because the simpler they are, the more optimized they are, and the less time they need to calculate. So, and convex hulls can be generated by the engine itself, and but unfortunately, the default value of that will be basically determined by Unreal itself. Now, that is determined, so these colliders will use the default collision complexity. And so it uses the default collision complexity. That means it has a default value. Maybe you could change that, I'm not sure, but don't take my words on it. And can be used for physics simulation and collision. So this convex hulls that Unreal can generate for you can be used for simulation and collision. The only downside is it has a default collision value, complexity, and you can't change it. So we'll read more and let you all know more. And so in order to use the convex hulls, it says that we need our name, we need it in our name convention to state UCX. So we can say collision geo for one that is invisible, as we see here, and rendered collision geo, as we see here, the rendered one, and end with UCX at the end at the prefix. Okay, so far we know, sorry. So we will have a convex hull that will be calculated from the group's geometry. So the geometry of the group that starts with that ends with the UCX in their naming group will be created, and it will assign an actor to it. And it will only be generated by the geometry of that group and by that geometry only. Okay, so let's learn and add on all of that. If you have added to your group a multi at the end after you've added the UCX, you will be able to use that feature that basically simplifies whatever geometry you have imported. And that from left to right, we have rendered collision geo, wait, this is rendered collision geo, and then the next one on the middle is rendered collision geo UCX. That's kind of cool. And collision geo UCX. All right, so but I think they needed to add multi here to make it more understandable, because UCX will only take the general one. I don't know, we'll keep basically learning about this even more. Are covering a new type of collision, which is called simple collision, which, as we can see here in the picture, is basically a very simple collision, and it could be made of a box or a sphere or a capsule or something called KDOB, but we should know what a KDOB is, but right now I don't know. So these colliders will use the default collision complexity of those shapes and can be used for both physics, simulation, and collision. So maybe we'll use those, but I think we'll end up using our naming convention, random collision geo or random collision geo UCX. We'll see about that. For simple colliders, all right, I'm gonna keep going and give you the essence of what I'm reading. All right, so if you want to use that, we need to add to our thing at the end simple instead of UCX or whatever else, and of course rendered will be the rendered one. If you want part to be also visible, yes, exactly, and a simple collider will be generated upon cook. So basically a simple collider will be created as such, either a box or a sphere or this thing here, and we will see what that means inside of here. All right, so by default a DOP26 collider will be created, exactly, but you can specify the type by the desired colliders by appending it to the group name. So basically we can append those to the group name: box, capsule, sphere, KDOP 10X or KDOP 10Y or KDOP 10Z. Actually, yeah, okay, let's keep going. KDOP 18 or KDOP 26. I think those basically group all this stuff. For example, collision geo, simple, sphere, and whatever comes after that. So, and another example, rendered collision geo, simple, and then YYY, KDOP 10X. So yeah, let's check that later. From left to right, rendered collision geo simple box, here you go. Rendered collision geo simple sphere, here you go. And rendered collision geo simple capsule, that's cool. All right, let's see what's next. From left to right, rendered collision geo simple KDOP 10X, this one. And rendered geo simple KDOP 10Y, which will put it in the Y-axis. And it's the Z, KDOP 10Z, which will put it in the Z-axis. This one is in the X-axis, Y-axis, the Z-axis. That's kind of cool, depending on what is the main thing for your character. So, for example, this head will be the one that faces in the Z-axis. I think the one that makes the most sense. Good stuff so far. And here we have one last thing from left to right. Rendered collision geo simple KDOP 18, which has more resolution. You can see on the nose it's coming forward. Or rendered collision geo simple KDOP 26, which has 26 sides without assigning X, Y, or Z. Doesn't matter. It just is doing the KDOP for it. That's amazing. You can maybe have like a whole character with those KDOPs, and if you know like exactly the performance of your platform, for example, if you're doing something for PC or if you're doing something for PlayStation, I guess for PC you would have it dynamically changing. As for PlayStation, I think we will have it fixed. So PlayStation 4 will be different from PlayStation 5 in the collision part. So game will feel more realistic maybe. But yeah, that is what I understand so far. I think the more resolution you need is like when you're in a boss fight, because you want like the accuracy of the sword hitting the boss to be like super accurate, or if you want like the face to have a nice simulation breaking down, etc. All right, let's keep going. So we have here, if your HDA has multiple level of detail, so LOD, and some HDAs do, you could assign an LOD by putting that name convention, which is Unreal U property, and then LOD for collision detail attribute. We don't have LOD, I think, yet, or we won't do that. So for now, it's important to just know that this is possible. And then you can assign the level you want of that collision. We have splitting, and this one we might use today or in the coming days, because today is pretty late now. Yeah, so we might use that later. Play that real quickly, and then we'll wrap this up today. Splitting is important if you have a door or something like here, like a tunnel, right? And you don't want the people to collide in it, right? So this is helpful to do that, and you could add it in collision geo simple 1 or collision geo simple 2, and the number here will determine what collision geometry will be split only if their collision group names are different. In order to get two simple box colliders on a mesh, for example, you will need to name them collision geo simple 1 and collision geo simple 2, and we will see what that means. Single convex collider on the left against 4 convex colliders on the right. Yeah, that is what it means. And let's see which one is named what. The 4 convex colliders on the right were created by assigning part of the arc to 4 UCX collision groups with different names. That's cool. Collision geo UCX far left, collision geo UCX mid left, collision. Wow, that's interesting. So you have to assign those names for each and every collision divider. That's interesting. We'll keep that in mind, and we'll keep going forward. These are very important, the naming conventions. Following is a list of all the possible group name prefix, and we will use now all of those naming conventions, which we have read about now upwards in tomorrow's stream, most likely, to set this thing up with the Houdini thingy. So because we have a collision here, we'll see how we can set this up with our Vex to communicate with Houdini and make sense of the whole thing. All right, so this is Unreal. Let me show you what we've done so far. And if we go here and give this a less of a mass, something of 500 maybe, and save it, and then go back into Unreal, start the simulation. This is what we've been doing today so far. A lot of talk about the technicality of things, but this is what we will be doing. We will basically continue into making this work a bit smarter. Yes, we have a collision here. All right, everyone, thank you for watching the stream, and thank you for watching the video. As always, subscribe and like, and if you haven't followed me yet on Twitch and on whatever you're watching this, follow me. I'll really heartily appreciate your support. And yeah, stay tuned for tomorrow's stream. Same time, and the finished version of today's stream will be uploaded tomorrow because I won't be making the edit today. All right, everyone, thank you for joining, and I'll see you tomorrow. Bye.